Hello everyone, welcome back to my video tutorial. This time I will be talking about one of the 3D transformation, that is scaling. 3D scaling about origin changes the size of the object and repositions the object relative to the coordinate origin. So here we have a matrices for 3D scaling, and when we multiply this matrix, we will get x dash will be equals to s of x into x plus 0 plus 0 plus 0. Okay, so x dash will be equals to scaling factor s of x into your old x coordinate. Okay, and y dash, your new y dash, will be equals to, likewise, you will get 0 plus s of y into y plus 0 plus 0. So y dash will be equals to scaling factor s of y into y. Okay, likewise, z dash will also be equals to s of z into z. So your new coordinate p dash will be equals to the scaling factor s and your old p. So we will either have to increase the size of the object or reduce the size of the object according to the value sx, sy, and sz. Now let us see this again. The term scaling factor is used to define whether the size of the object is increased or decreased. We can represent the scaling factor by s of sx for the x-axis, sy for the y-axis, and sz for the z-axis. The increment and decrement of the object depends on two conditions. They are if scaling factor sx, sy, sz is greater than 1, then the size of the object increases. If scaling factor sx, sy, and sz is less than 1, then the size of the object decreased. Okay, so it will depend on either the scaling factor is less than or greater than 1. Now let's see this about any fixed point. So here, this is the object we want to scale, and as you can see from here, this point, this small point there, which is in the red dot here, we have to bring this to the 0, 0, 0 axis of x, y, and z. Okay, so when we see this is the original position of the object, we have to translate this object to the origin of the x and y axis. That is, this value has to become 0, 0, 0 on the x-axis, y, and z-axis. Okay, so we will bring down this point on 0, 0, 0 of the x, y, and z. That is, we are translating it, and then after that we scale it. Scale means here in this case we are increasing the size of this object, and after that we are going to bring back to the original position. Okay, so here is the original position, the red dot is the original position. So this is how scaling is done if the object is not on the initial 0, 0, 0 of the x, y, and z axis. And in this case, we are going to translate it first, and then we are going to scale it, and then we are going to inverse translate. All right. First, we are translating it, as you can see here. Second, we are scaling it, and then the third, we are inverse translating it. All right. So this is the xf, yf, and zf for translating, and minus xf, minus yf, and minus zf for inverse translating. This, whatever the position that we change, will be inverse by this negative inverse. Okay, so in this particular case, we will have a scaling matrix like this. All right, 1 minus sx bracket x of f. This is for your translation. All right. Now let us give an example. A 3D object that have coordinates point P1, 4, 4, Q4, 4, 6, R, 4, 1, 2, T, 1, 1, 1, and the scaling parameters are 3 along the with x-axis, 4 along with y-axis, and 4 along with z-axis. Okay. Now let us solve this. So what we have here is we have 3 scaling factor s of sx, is equals to 3 along the x-axis, Sy is equals to 4 along the y-axis, and Sz equals to 4 along the z-axis. Okay, so now let us consider point P. We already have that the new axis x dash will be equals to s of x into x, the old one, and new y will be as y dash will be equals to sy into the old y, and z dash will also be equals to sz into old z. Okay, so considering this formula, let us apply this formula for point P, comma 1, 4, 4. Here we will get x dash will be equals to 3 into 1, which is equals to 3. Y dash will be equals to 4 into 4, which is 16. Z dash will be equals to 4 into 4, which is again 16. So the new point P dash will have the value 1, 4, 4. Okay. Now let us consider point Q, which is having 4, 4, 6. X dash will be equals to 3 into 4, which is 12. And y dash will be equals to 4 into 4, which is 16. And z dash will be equals to 4 into 6, which is 24. All right. Now new point Q dash will be equals to 12, 16, and 24. All right. Now let us consider point R 4, 1, 2. 4, 1, 2. Here in this case, x dash will be equals to 3 into 4, which is 12. Y dash will be equals to 4 into 1, which is 4. And z dash will be equals to 4 into 2, which is 8. All right. And then we will have point R dash will be equals to, R dash will have point 12, 4, and 8. Now let us consider another point T, 1, 1, 1, 1, 1, 1. So here x dash for point T will be 3 into 1, which is 3. Y dash will be equals to 4 into 1, which is 4. And z dash will be equals to 4 into 1, which is 4. Now the t dash will have a point 3, 4, 4. So considering all these points, the new coordinate that we are going to have for new coordinate that we are going to have are P dash 1, 4, 4, Q dash 12, 16, 24, R dash 12, 4, 8, and T dash 3, 4, 4. Okay, this is the new coordinate we are going to have. So that is all for this lecture. Thank you very much. See you in the next class.